Wearable devices have become very popular. Among them, the most used are wrist wearables such as smartbands or smartwatches. These devices are frequently used by sports people as activity trackers for monitoring and tracking fitness-related metrics. Sensors available in these devices allow to collect data such as users' geolocation, movement patterns, steps taken, or heart rate, among others. This data can be processed using data analytics techniques to estimate the value of variables such as distance walked, calories consumed, maximal aerobic capacity, or sleep quality. These devices are starting to be introduced in other domains such as health or education.
In our case, we decided to explore the possibility of using commercial wrist wearables in an academic context. More specifically, our work focuses on estimating stress in students using these devices. For this, we measure variations in physiological signals such as heart rate, skin temperature, or sweating during the performance of different training activities. Then, machine learning techniques are applied to these signals to estimate stress levels.
Commercial off-the-shelf wrist wearables devices have sensors that provide information on physiological signals that have been widely used by the scientific community in stress assessment and detection. Among these signals, heart rate, respiratory rate, skin temperature, or galvanic skin response are the most common. To carry out this study, an evaluation protocol has been defined in which the following tools are used. A commercial wrist wearable that is provided to the student to capture physiological signals. And a smartphone running an application developed at OC to collect data and submit